3.66 gram per day.
Yes, sir.
Why?
Yes, sir. Sir, 235.1 minus 183.8 gram equals to 51.3 gram.
Hmm.
Then average per day equals to, sir, 51.3 divided by 14. Sir, comes 3.66 gram per day.
51.3 divided by 40.
14, sir.
Then how
Sir,
much?
3.66. 3.66 gram.
3.67.
No, sir, 3.66.
So after 66, what are the digits?
4, sir. 4.2.
So 3.6642. Okay, then we can write 3.66. Then gram per
Day.
day. Okay, so left side they already gave a loss of mass per day. Then we are saying 3.66 gram. Done. This part is done. The next.
Yeah.
Yes.
Sir. A
Yeah.
second student carries out same experiment with beaker of larger diameter. The students compare their results and conclude that the rate of evaporation increases with surface area. Said the other quantities that must have the same in the experiment if they can sure of their conclusion.
Yes. So what should be the same? What other?
Sir, sir, increase in temperature and the first one.
No, no,
And
no.
sir,
They
wind blowing.
they
Sir,
are saying you uh, they are doing the experiment to observe the effect of surface area, right?
yes, sir.
Previously they were using smaller diameter beaker, now they are using larger diameter beaker, right? So to make this experiment accurate and to make this experiment more understandable, so which things they must keep same? That means you have to keep the factors
Liquid.
remain same.
Liquid.
Like you can bring the idea like temperature
Yes,
should
sir.
be constant, right?
Sir, the
And
temperature should be constant.
the other factors you can bring also, like humid should be
Sir,
constant. then
humidity should be constant.
then the
Sir,
one is,
the liquids must be same. Sir, the liquid must be same.
yeah, amount of liquid or volume of liquid must be same.
Yes,
So
sir.
you
Sir,
better bring two ideas mostly important. One is
sir,
amount
const.
of volume. Yeah, that means volume of the liquid should be constant and the temperature should be constant. Okay.
Sir, amount of liquid must be same, right?
Yes, amount of liquid should be same or the volume or should be same thing. Same means
And
constant,
sir,
right?
yes, sir. And sir, the second point is the temperature must be constant.
Yes. So we are doing the theory part related to evaporation. We are having
Yes,
also the practical, right?
yes,
We are
sir.
also having the practical related to evaporation. So they are matching each other, right? It's good to have the similar discussion with practical and theory, isn't it?
Yes, sir.
Then next,
So next, Sir, the experiment took 14 days to complete. In order to carry out the experiment in shorter time, suggest a piece of apparatus that increase the rate of evaporation.
Okay.
Sir, there are many, sir.
You bring
Like,
one
sir,
apparatus in order to carry
sir,
out the experiment in a shorter time.
sir,
Suggest,
Bunsen burner, sir.
yes, you can increase the temperature, right? By using Bunsen
Yes, sir.
burner. Then,
Then, sir, a fan, sir, fan.
yes, yes, yes. Fan, you can bring a fan. Okay, very good. Very good. So you can write
Sir, which one should I write, sir?
anyone you like, no problem. Anyone you like. So this experiment is over, huh? Now we have another experiment. We have two experiments today.
Okay, sir.
And this one is related to specific heat capacity. That's why I brought this experiment for you. The second one, that
Yes,
is
sir.
this experiment. Okay, continue this, please.
Yes, sir. A student determines the specific heat capacity of aluminum. The student has been provided with a thermometer heater, an aluminum block of mass 1 kg with holes for the heater and thermometer, a DC power supply, an ammeter, a voltage meter, a stop clock.
So
On
we
fig
have an
3.
emitter. You
Yes, sir.
pronounce it as emitter, huh?
Yes, sir. Ammeter, sir.
Then voltmeter,
Yes, sir. Voltmeter.
a
Ammeter,
stop
voltmeter, stop
clock.
clock. A
Yes.
stopwatch,
Then
same thing.
yeah.
On
Then
fig
continue.
3.1, complete the circuit diagram to connect the heater to the power supply, the ammeter, and the voltage meter.
So these things are not familiar with you. You don't have idea about this. However, now you will get the idea. Now you see what I'm doing. You do the same thing. Huh? So we
Yes,
have
sir.
here one thing that emitter, right?
Yes, sir.
Emitter should be connected in series. This one is series connection, and voltmeter should be connected in parallel with the heater. I'm showing you how to do it. And voltmeter is this one.
Yes, sir.
So A stands for ammeter, huh? And V stands for
Yes.
voltmeter.
Sir, what is the A in the ammeter, sir?
Ammeter measures the current, and voltmeter
No,
measures
no,
the
sir. Sir,
voltage.
actually, sir, which one is parallel, sir, and which one is in series, sir? Can you explain that one,
Okay,
sir?
here the one you see, your voltmeter is connected to the
Yes,
heater in parallel. Okay, you
yes,
see,
sir.
both the ends of voltmeter is connected to the two ends of the heater, isn't it?
Yes, sir.
And ammeter, only one is end is connected to the heater, another end is connected to the power supply. That's why it is series. Okay, when the components are connected one after another, that is called series. And when the components are connected this way, both the ends are connected together with the component, that is called parallel. Is it clear?
Yes, sir.
Okay, very good. Now we are continuing. Look, you are learning, right? If someone is
Yes,
attending in
sir.
class, they are learning actually. Every day you are learning. Every day, every moment you are learning. So you don't worry, huh? you be present in class. So your drawing is done,
Yes,
right?
sir.
This
Yes,
one
sir.
you,
A little bit left, sir.
yeah, should I keep it there? Okay, you finished drawing, yeah? You do not need to, draw all these things on
Yes,
your
sir.
paper.
Done,
You
sir.
just write here it is heater, okay? Then you,
Sir,
uh,
I did the whole thing, sir.
yeah,
So yes, sir. Done, sir.
okay, done. Now we are going to the next, yes, this one.
Yes, sir. Initially, the block is at room temperature, which is 23.5 degrees Celsius. The student switches on the power supply and starts the stop clock.
Yes,
Uh,
at the same
Starts the
instant.
stop clock at the same. Sir, what is mean by the same instant, sir?
When the same moment,
Oh,
same
okay,
time,
sir. Same instant.
same time,
The
same time.
the yes, sir. The ammeter and voltage readings are shown. Which one is
Yes.
sorry, this is the ammeter.
So the
So
first
like
one
the
is
left one
emitter.
ammeter, sir.
Yeah, the
The
first
second
one
one is
is
the voltage
emitter.
one.
It's written A. That means which one is measuring current, ampere.
Yes,
That
sir.
is emitter. Which one is measuring the voltage? That is called voltmeter. Okay. So record these readings.
Yes, sir.
I
I
for
is for
current,
sir.
current.
Yes, sir. Ammeter. Yes, sir.
I for current and V for voltage. So you
Sir, sir. I see 1.2, sir.
I is
1.2 ampere.
I is coming 1.2. So you write 1.2 ampere.
Yes, sir. A, right, sir.
Yes. Then for voltmeter, voltage reading, how much you are getting?
Sir, for the voltage, sir, it is coming, sir. 8.6, sir.
Yes, very good. So we are getting here 8.6 volt.
Volts.
Done, huh?
Yes, sir. Done.
So this part is done. Now we are going to next part. We are having next part. Okay, can you continue, please?
After
Yeah.
10 minutes, the power supply is switched off. The maximum temperature reading on thermometer is 29.0 degrees Celsius. The specific heat capacity C of the aluminum block is given by C equals IVT by MC
M
M
del
delta
theta.
theta.
So you got the
Yes, sir.
same formula, right? You got before. C equals
Yes,
Q
sir.
by M del theta. So you write here Q equals IVT.
Yes, sir.
Q equals E equals IVT. E for energy, right? Electrical energy. And Q for heat energy. So from electrical energy you are getting the heat energy, isn't it?
So Q equals IVT and the formula is C equals
Yes.
IVT by M delta theta. Yes, sir. Let me do the calculations. So
So what is the time
1.2
here?
into
What is the time here?
8.6. Sir, 10 minutes, sir. Sir, 10
10.
minutes, sir, 10 into 60, sir.
Very good, very good. So you have to convert to
600. 600
seconds,
seconds.
right? Minute to seconds. Then
Yes,
next,
sir. Sir, then next, sir. So the mass is
your
1.
del theta.
Sir, delta, sir. Sir, can you show the sir, temperature, sir?
Yeah, here
The
is
first
temperature reading maximum one
29.
is 29, and your
The first,
previous one
sir,
was 23,
23.5.
23.5. Yes.
Yes, 29 minus 23.5. Sir, that is, sir, 5.5.
Yes.
1.28 and 8.6 into 600 divided by 1 into 5.5. Yes, sir. Sir, give me a minute, sir. Let me just calculate.
Sure, sure, sure. So how much is coming?
Uh, sir, I, sir, I made a mistake, sir. Sir, 11,025.82.
$11,000.
Sir, 11,025.82, sir.
1025.82.
82. Yes, sir.
82 joules per kg
Degree Celsius.
degree Celsius. Okay. So this way, right? We are getting. Now they
Yes,
told
sir.
us to find the answer in two significant figures.
Two significant figures.
Yes. So how you'll write it? You'll write it this way. Are you sure it is 11,000 or 1100? What? Did you do all
Sir,
these things?
11. Yes, sir. 11,025.8.
Okay.
81. Sir, sometimes it is coming 81 and sometimes it, sir, it comes 81. But the next digit is 8. So it will be
Okay, then
82, right,
82.
sir?
82. Fine. Now,
Yes, sir.
if
82.
it is two significant figures, then you have to write 11,000. Is
How,
it
sir?
clear?
No, sir, not clear, sir. Two significant figures.
That means we are we are rounding it up. Okay, to 1,000.
Oh, sir. One mistake.
Yes. Tell me what is the mistake?
Sir, 1100, sir, not 11,000,
That
sir.
one I was asking you. It is 1100 or 11,000?
Yes, sir. I made the mistake. It came 1125, but I said
Yeah, 11. That's why I asked you
1125. You 82
1125.82 joules per kg
degrees
degree
Celsius.
Celsius, right? Degree
Yes, sir.
Celsius. Then we are having 1100, right? Two significant figures.
Yes, sir.
Joule per kg degree Celsius, right? Is it
Yes, sir.
clear? Now the
Yes, sir.
last part. Can you read?
Yes, sir. The accepted value for C is different to the value obtained. Suggests two reasons why this is so.
Okay. So it is so. It is for this all factors, right? Like
Which
when you are
factors?
measuring
Yes.
the temperature, there might be some problems. When you are measuring the time, there might be some problems. When you are measuring the current voltage, that time also some problems. For these issues, we might have different.
So the first one is, sir. The first one I am writing, sir. When we are measuring the time, when we
Yes,
are measuring the ta- time, there might be an error.
yes. Then normally, what we do for stopwatch, we always take average because there might be some
Yes, sir.
random error, right?
Yes,
While we
sir.
are
Random
yeah,
error.
yeah, to reduce the random error, we have to take average. Maybe you are taking three readings or you are taking five readings, then you are taking the
Yes, sir.
average.
Yes, sir. I know that, sir. And the second one I'm writing, sir. There might be an error in measuring the value of
Temperature, right? There might be some problem with temperature, right? Mohammed Saad. Hello, Saad. Hello, Saad. Mohammed Saad.